Hello guys, so in this video, we will be understanding the difference between concurrency and parallelism. So in my introductory video, I showed you my system specs and how a C program is getting executed and all the calls that are happening between RAM to cache, cache to uh, cores, and inside the core multiple AGUs, ALUs, some SIMD units, and how they are interacting. I will make a separate video of that, and I will step by step show you and also tell you like what are those components. But in this video, like before starting of the series, okay, I would like to tell you the difference between concurrency and parallelism. Okay, now before going forward, okay, so those of you who wants to like code with me and stay updated with the course, okay, uh, you guys need to install few of the things. Okay, so first thing first, okay, so I'm a Windows user. I'm using Windows 11, and in that I have installed WSL. Okay, so as you can see, I can create a Ubuntu instance here. Okay, now uh, why using WSL? Because using WSL, you will be able to execute all the helper utilities that are available in Linux. Okay, so first of all, how to install WSL? So just search for install WSL. So you will get this link. Okay, so you can go through all the steps how to install WSL. So yeah, that's it. So once you install WSL, you will be able to open up a Ubuntu terminal just like this. Okay, now using Ubuntu terminal, you can run a simple command which is lscpu, which I have showed you in my previous video. Now using lscpu, you will have the whole system specs that you require to know about your system. Okay, so for example, my architecture is x30 x8664, and my CPU can compute 32-bit and 64-bit operations. And as you can see, like I have 32 cores, and in each of the core I have two threads. Okay, and which means like if hyperthreading is involved, I can simply say I have 64 virtual CPUs. Okay, and also you will be able to see whether you can execute SIMD type execution. As you can see, like I have AVX 512, which means like I can simultaneously execute 512 instructions at a time. Okay, so I'll make a separate video of what is like SIMD is actually means. Okay, is SIMD, SPMD, all those parallel programming paradigms. Okay, but yeah, the point here is, so if you are a Windows user, just install WSL so that you can uh, use LSCPU. But if you're sticking to Windows, you can use your task manager. Okay, just go to performance, and here you can go to like memory, CPU, and all that. Okay, now in CPU, you can see like what's your CPU utilization, how many P threads you are generating, how many processes are running. You can also get the specs of your L1, L2, L3 caches. But the distinction here is, um, as you can see here, okay, caches. Okay, so here I have the per instance count also. Okay, so I have two types of L1 cache, one for data reading and another for instruction reading. Okay, L1D, L1I. I have 16 instances of L2 cache. Okay, here I'm not getting the instance count. Okay, and yeah, acha, also one thing to note here is, I guess here I told like 64 cores, but yeah, these are like 32 virtual cores. Okay, not 64 cores. I do not have 64 cores. I have 64 gigs of RAM. Okay, as you can see here. So 4 GB of them are occupied by systems. So available is 61.6, where I'm consuming 33% of this. Cool. So yeah, now other thing you need to have is top. Okay, just be aware of top command. Okay, so top command will help you to list down the processors, like processes that you are running in your system, and it will show you how much of memory you are utilizing. As you can see here, this, okay. Now top is a Linux command, okay, so you will be able to run it inside your Linux shell. And yeah, now there is a other variant of your top command, okay. So you can use htop, which is analogous to your task manager, okay. So it just creates a terminal UI for you, so that you can monitor your processes as well as you can see your core utilization. So similar to your top command, you can see the memory and as well as the swap memory. Now one thing you will observe here is, so when you are installing WSL, okay, so it will take a part of your disk, okay, and it will assign it for WSL only. So similarly, a part of your RAM will be like will be allocated for your WS installation, okay. So as you can see, like I have 64 gigs of RAM, like okay, to be specific, 61.6 GB of RAM, okay. But here I'm only saying 31.1 GB, okay. But no need to worry about it, okay. So this memory is dynamic, okay, which means like if you are trying to allocate maybe 40 gigs of RAM, okay, so the WSL system manager will all will expand your memory to utilize more RAM, okay, from your 61, okay. So yeah, so that's about WSL and htop, okay. Now one more command you will be needing. So if you are having a GPU, okay, so try to search for nvtop, okay. So nvtop is similar to htop, but it's for GPU monitoring, okay. So it will give you a terminal UI to monitor your GPU. So I have a RTX 5070 Ti, so I have installed nvtop, so it will show you something like this. So here you can see your number of GPU devices you have. I have only one device, so that is device 0, and you can see like GeForce RTX 5070 Ti. It will also show you your VRAM, which is this. I have 16 GB, so allocated one is between 0.921 gigs, okay. It will also show you your GPU core utilization, okay, as you can see this, okay. Now sometimes it might happen like nvtop, you won't be able to install some packages or something, maybe there is a issue, okay. So there was one issue, like when I try to install nvtop in my laptop, so maybe I need to update WSL or something, but I was not able to install nvtop there. So in that case, one more point, so it will also show you your processes that are utilizing GPU, okay. So they will be listed down here. Now these processes will be listed down for only your WSL space, or so any process inside your WSL that is consuming your GPU, that will be listed down here. So you can monitor them if you find a hog or something, so you can kill them also. So yeah, now coming back to, if you're not able to install WSL, so you can install nvidia-smi, okay. So it's also a Linux command to monitor your GPU, okay, but it's a static command, which means like whenever you are executing, so at that point of time, what, like how much memory is required, okay, that will be shown, okay. And it will also show your CUDA version, okay, but it doesn't show you your course utilization and all that, like all those chart information. Now one way to make it dynamic is to install watch command, okay, watch. Now by installing watch command, it will keep on pinging your nvidia-smi command at a particular time interval. So let's say I want to ping nvidia-smi, or I want to run nvidia-smi every 3 seconds. So I can run nvidia watch minus n and 3 nvidia-smi. So every 3 second nvidia-smi command will be run, okay. So you can see like every 3 seconds it is running nvidia-smi, and let's say I will run something on this, okay. Let's search for a YouTube video. Okay, don't go through my thumbnails, okay. So let's run this, My Hero Academia. So yep, when I'm running this, okay, you'll see a spike here. Okay, it just continuously monitors it. Like not monitors it, we are pinging as nvidia-smi, so it gives me the state of that. So in that way, I'm making it dynamic. Okay, so if I play this, I just disable the sound. If I play this, now you will see some utilization here. So this is being changed dynamically because per 3 seconds we are polling it. Cool. So in this way, you can make nvidia-smi dynamic. Okay, so just Control C out of that. So watch will be closed. Cool. And with that, so with all of this installed, you should be able to monitor your system and you will be able to know your system well. Okay, cool. Now coming back to the main topic, which is concurrency versus parallelism. Okay, so what is concurrency and parallelism? Okay, so many people think like concurrency is same as parallelism, but that's not the case. Okay, so what concurrency says is, okay, if I draw out a distinction, concurrency, okay, and here I have parallelism. Okay, what concurrency says is managing multiple multiple tasks. Okay, it's basically says managing multiple tasks, okay, at a time. Okay, whereas parallelism says executing multiple tasks simultaneously. Yes, Lee. Okay, so here's a clear definition: concurrency and parallelism. So it's like managing multiple tasks at a time, and it's like executing multiple tasks simultaneously. Okay, now if I give you an example, okay, let's say you are in a restaurant. Okay, in a restaurant we have a chef. Okay, so let's get a chef picture. Chef icon. Let's okay, let's take this guy. Okay, if I paste this guy, okay, let's say this is a chef. Okay, let's say this guy has to do let's say it has to like he or she has to, let's say, boil the rice. Okay, okay, and let's say then it has to let's say make the gravy also. Okay, so let's say check the gravy. Okay, no, gravy. Okay, let's say he is the head chef, so it checks for all the sous chef, all their work. I don't know the hierarchy, I'm just saying sous chef and head chef, so please correct me in the comments. Okay, so let's say this guy boils the rice, boils the rice, checks every let's say checks every 1 second how the gravy is looking, and let's say he's also responsible for cutting the vegetables. Okay, okay, and again he has to check whether rice is boiled or not. Okay, so this guy is concurrently taking up all the tasks. Okay, he's doing boiling of the rice. Okay, when he has like switch on his gas. Okay, and he has boiled the rice. Now rice will be cooking, then he can check on the gravy, how are the sous chef doing. Okay, and then he satisfy or he will feedback to them. Okay, then he can go to cutting the vegetables. Okay, then once he has done cutting the vegetable, he can go back to boiling the rice. So this chef is doing concurrent execution. Okay, now let's say I take this chef. Okay, and in this restaurant, okay, let's say I have multiple chefs. Okay, there is chef 1. Okay, there is, okay, let's say I paste this. Now let's say I paste this here. Okay, there is chef 2 also, and let's say there is chef 3 also. Okay, now I have 3 chefs now: chef 1, chef 2, and I have chef 3. Okay, now chef 1 can do all its work concurrently, and simultaneously I will have a chef 2 that will also be doing the same amount same work simultaneously, and same as chef 3. Okay, Now their execution will be happening parallelly, okay? But internally, if you see, they are doing multiple work concurrently, okay? So each chef is managing its work concurrently, or managing its own task, okay? But when we broad the spectrum and we look at each chef, okay, we will be seeing parallel execution, okay? Now concurrency is basically managing, okay? That means when you are performing a task, okay, let's say you want to scrape multiple websites, let's say, and you have, let's say, 100 urls, okay? Let's say you have 100 urls, and let's say we usually spawn a threadpool worker to do that. Now in threadpool worker, we execute them concurrently, okay? So if I search for um, web scraping, let's say in Python, with the thread pull executor, give me a code example, bro. Okay, so yeah, back to the example. So let's say you are scraping 100 urls. So let's say here's the Python code. So in this Python code, when we are creating the thread pool executor, we are basically importing from concurrent.future. So in that, all the p threads that we are creating, okay, those are executing concurrently, okay? They are not simultaneously getting initialized and calling it to all the urls here, okay? So yeah, now let's come back to this example, okay? So in this flow, I have shown you like how concurrency is happening in the system and how parallelism is happening in the system, okay? So as you can see here, okay, I have written a C code here, okay? So here I'm just creating a couple of p threads. I'm creating like 4 p threads, and to each p thread I'm assigning some work, okay? And then I'm joining with the main thread, okay? So that it will wait till all the p threads have completed their execution, okay? Cool. Now let's see the concurrency one, okay? So in this flow, okay, what I have shown you is that in this system where concurrent execution is happening, I have only one logical CPU, okay? Only, or you can think of like one CPU, okay? I'm creating multiple p threads, okay? Now when I'm creating multiple p threads, okay, all those threads are getting uh, taken by my OS, okay, which takes the instruction or takes the command to create p threads, okay? So till user space or till my code block, okay, I'm only writing the command to create p threads. OS takes up that command and it tells the Linux kernel that, hey, the user is requiring to create some p threads, please create it for me, okay? Now the Linux kernel, okay, it will be creating all these p threads and scheduling them, okay, on your hardware, okay? So this scheduling, what is happening, that is done by this CFS scheduler, okay? Now CFS is a Linux based scheduler. It basically stands for completely fair scheduler. What it tries to do is, the worker thread that you have, which is basically this logical CPU, it tries to allocate CPU resources equally to all the to all the worker threads, okay, so that there will be symmetric execution, okay? And in all our OSs, okay, we generally have a preemptive type of scheduling, okay? So I'll talk about preemptive and cooperative scheduling, okay? But just keep the concept in mind, okay? Whenever you are creating a thread pool executor something, or maybe process pool executors, something like that, okay, you are basically instructing the OS to create those things, okay? Now the OS delegates that commands to your Linux kernel, okay, which actually talks to the hardware and creates all your p threads, okay, and then schedules them, okay? Now here what we are seeing is concurrent execution, because all my threads, okay, they are being queued, okay? And you can see like one by one A and B are getting queued, okay? And they are scheduled, and they are taking up the worker, which is the CPU, and running that job. Okay, now coming to parallel execution. Okay, in parallel execution, okay, here I only had one core. Okay, here I have shown you four cores. Okay, here when I'm creating multiple threads, or I'm trying multiple p threads, okay, the OS takes that command. Okay, then it asks the Linux, like it tells the Linux kernel like, hey, the user is requiring to you, or like requiring some p threads, please create them. Now when I have multiple core, okay, now this scheduler can schedule those thread into multiple cores. As you can see, like ABC are coming. Okay, they are taken up by OS, they are taken up by kernel, and then they are mapped to different cores. Okay, whereas when I have only one core, okay, the kernel is scheduling them using some time slicing concept that I will talk about. Okay, and it's basically doing a round robin fashion. Okay, you can think of a round robin fashion to schedule them inside one core. Okay, so on an overview, if you are looking at this picture, you will see that multiple tasks are being executed, but when you zoomed in, you will see that only one task is being executed at a time. Okay, but on an overview, you will see multiple tasks are executed. Okay, now coming to parallelism. Okay, when you are seeing here, okay, you are basically seeing multiple tasks are being executed simultaneously inside different core. Okay, so this is parallelism. Okay, now in this concurrency versus parallelism model, okay, there are a couple of things that we have to discuss. Is like, what is context switching? Okay, as you can see here, ABC are coming. Okay, and they are kind of cyclically executing their job and coming, going back to the queue and all that. Okay, so right now I'm only showing you like everyone is doing their job and done with their task. Okay, but in a heavy computing kind of environment, usually we have a round robin fashion where we have some time slicing where the first task gets back into the queue so that other task will be executed. Okay, so we will talk about that in the next video. We will also talk about different scheduling paradigms, and based upon those paradigms, how different programming languages are created. Okay, so how C++, Python, or maybe Haskell, Rust, Java, like what paradigms are they using. So we will talk about that in the next video. Now, to conclude this video, I'll just show you one example in Go. Okay, about concurrent execution. Okay, so in this I have opened Go playground. Okay, so what I have done is I have written this main function. Okay, where I'm creating some Go routines. So we will talk about Go routines in follow-up videos. Okay, so what is happening is I'm doing this task concurrently. Okay, so when I'm creating my main function, okay, the main thread is creating a Go routine. Basically, it parallelly or like concurrently creating another thread, you can think. Okay, thread, and simultaneously for task B also it is creating another thread. Okay, now let's see what task definition is. So task takes a names. Okay, it takes a string value and it just sleeps off 3 times for 500 milliseconds. Okay, like 0.5 second. Okay, and yeah, now to hold off my main thread, okay, I'm just creeping like telling a sleep command over my main thread to sleep for 2 seconds, so that within those 2 seconds these Go routines will complete their execution. Okay, now if I run this, okay, you will see the tasks are being executed. Okay, like this. Okay, now one thing to note, that the order of execution, I do not have any idea like how will they execute. If I run it again, you will see a different ordering. Okay, but I'm sure that they will be executed within that time limit. Okay, cool. So we will talk about like what is happening under the hood. Okay, so I cannot say they are happening parallelly, but I can say they are happening concurrently. Okay, so yeah, all these concepts we will be covering in the next video. So the take on from this video is about the difference between concurrency and parallelism. Okay, so just keep that in mind, so that in the next video you will be able to understand the impact of scheduling. Okay, and how like what all things are running under the hood when you are creating distributed computing and all that. Okay, so till then, just stay hungry to learn more and to learn new concepts. So yeah, and if you learn something new, please do subscribe to the channel, and you can post a comment if you have any doubts. I'll be happy to answer them. Okay, cool. Till then, bye bye.